Hello guys, and welcome back to another episode of chemistry. It's chemistry today again. All right, and today we are going to continue our study on acid, bases and salts, especially pH. All right, so we're going to be looking at buffers. All right, these are what solutions anyway. All right, do not forget also that this video tutorial is brought to you by the best CBT practice app available that has made thousands of students over the year to gain admission into the university, called the O3SCHOOLS JAMB CBT practice app. It is the best CBT practice app available out there for you to study and practice. There's a study mode, there's a practice mode, there's an exam mode, there's a mock mode. You can take any of this mode to practice by yourself. And there's a wonderful feature called the UTME challenge that is being conducted every week for all JAMBites. All right, you participate in that challenge, you win prizes, and winning the prizes is not really the major reason why we take that challenge. For example, if every week you take the challenge, participate in the challenge till 1 week, you participate in the challenge every weekend till 1 week to your JAMB exam. Let's say in your first challenge you scored 60 in maths, 70 in chemistry, 30 in English, 40 in biology, or any other subject. So from here now, once you see your scores, you know that this is your in math. Yes, this is your mathematics, for example. This is your chemistry. This is your biology. This is your English. All right. Let's say you take a test and you see a score like this. You know that your maths is a little bit okay. It's not as if it is perfect, but you know that 60 is good to be. Let's say you have taken this text like 5 times, 7 times, and you are having an average of this course in your test. You should know that your maths is a little bit okay, your chemistry is a little bit okay, but your biology is terrible, and your English is terrible. It will make you to know that you have to focus on these two. All right. So let's say, for example, your physics is also low. You know that your physics is poor, and you need to take lessons on physics. All subjects, all topics on all subjects are on this channel, so you have everything to succeed. And with the app, that's the last bullet, that is the last shot that you need to take at your exam. Please do not forget to head over to Play Store immediately, download it. The app is available for both laptop and PCs and Android phones and even iPhones very soon. All right, so please take advantage of this unique opportunity to download the app and study. All right, enough about the app. Know that activation is just 3,000 naira as opposed to 2,500 naira the previous years. All right, so please, it keep going up because the cost of things keep on increasing. It will keep going up. So don't just pass your JAMB at once. All right, now buffers. Now, what are buffers? A buffer solution is any solution that resists changes in pH. Right? pH when little quantities of acids or bases are added to it or to them. All right. So a buffer solution is any solution that resists changes in pH when little quantities of acid or bases are added to them. All right. That means when you add acids or you add bases to buffers, right? They resist that change. They resist that change in pH. The pH of all of the solution will not change. Now let's take a look at it closely. If you have an ordinary solution, right? An ordinary solution. All right, and then we add acid to this ordinary solution. All right, so when we add acid to this ordinary solution, what it means is that we are adding hydrogen ions to the solution. When we are adding acid to an ordinary solution, it means we are adding hydrogen ions to the solution, and this in turn means we are increasing the hydrogen ion concentration of the solution. All right, when we're adding acid, take note of this very well. If you're adding acid to an ordinary solution, it means we're adding what? Hydrogen ions to that solution. And this in turn means what? We're increasing the what? The hydrogen ion concentration. That is this one. We're increasing the hydrogen ion concentration of the solution. All right. This in turn will what? Will make the pH to what? To drop. All right. So the pH what? Will reduce. All right. So when we add acid to another solution, it means we're adding hydrogen ions to the solution, and it means we're increasing the hydrogen ion concentration, and it means that what? That the pH will drop. Please note that and note please. Right? So adding acid, I'm going over it again for the last time. Adding acid to an ordinary solution means what? Adding what? Hydrogen ions. Adding hydrogen ions. It means increasing the hydrogen ion concentration, and that means that what? After doing this, the pH will drop. Now, on the other hand, when we are adding base to an ordinary solution, it means, of course, I'm also adding what? Hydroxyl or hydroxide what? Ion to the what? To the solution. And it means we are adding this. First of all, let me put adding. We are adding OH ion to the what? To the solution. It also means that what? We are removing hydrogen ions from the what? From the solution. It means we are removing hydrogen ions from the what? From the solution. And because of this, it means that what? That the pH will what? Will increase. The pH will increase. The pH will what? Increase. It will not drop. Right? So let's get this very clearly. When we're adding a base, right, it means we're adding hydroxyl ion, all right, and then that means we are removing what? Hydrogen ions, right, and that means that the pH will what? Will increase. It will go up. Let's look at it like we're having our pH meter. Our pH meter from 0 to 14, all right. A pH meter like this. Let's say from 0 here to what? To 14. Let's look at it like this, and then 0.7 here is the neutral point, right? Let's say we're adding what? We're adding acid to this what? Neutral solution that is neither what? Acidic or what? Basic. You get now. So if we are adding what? Acid to what? This neutral solution, it means that what? That the pH, that the acidity of what? That solution will become stronger, and that means what? The pH will drop, because for acids, this is for acids. Acids have lower pH, right, than bases. All right. So the pH will drop. You get. That's why we're saying the pH will drop here. So now on the other hand, adding base to a neutral solution, for example, it means we're adding what? Hydroxyl ion. And because we're adding hydroxyl ion to the solution, it means that what? That the pH, of course, will go higher, because this is for base. We're adding what? Hydroxyl ion. It means what? The pH will increase. The pH will not drop. You get. So this is just simple what to understand. Now, but for buffers, adding what? Acids or bases to buffer also means adding hydrogen ion to the solution, or adding what? Hydroxyl ion to the solution. For buffers also is the same. When we're adding acid or bases, it means we're also adding hydrogen ion or hydroxyl ion to the solution. There is no difference. Anyway, the only difference here is that what? That the hydrogen ion or the hydroxyl ion that are added to the what? To the solution are mopped out. They are mopped out. They are mopped out. It means they are absorbed. They are absorbed, or they are buffered. We say they are buffered, right, from the solution, so that their effect is not seen, so that their effect is not noticeable, so that their effect is not what? Noticeable. So when we are adding what? Hydrogen ion, adding acid to buffers now, it also means we're adding hydrogen ion or the hydroxyl ion to the solution. But the difference is that what? The hydrogen ions or the hydroxyl ion that are added are mopped out. They are what? Absorbed. They are what? They are buffered. All right. So this is what happens to what? It happens in what? In buffers. Now, before I tell you why or how these hydrogen ions or hydroxyl ions are mopped out, or how they are absorbed, or how they are buffered from the solution, let's see the types of what? Buffers that we have. First, there are two basic types of buffers. Let's look at them, and then after then I will show you how what this effect is what is neutralized. All right. So now let's see the types of buffers. So there are two basic types of buffers. We have acidic buffers acidic buffers, and then we have alkaline buffers. Types of buffers. All right. So number one, like I said, we have acidic buffers. One, acidic buffers. All right. And then number two, alkaline buffers. So questions on buffers come out a lot in JAMB. They come out a lot in JAMB chemistry, right? Examiner tests you on what on buffers and understanding of what how acid and bases are what are added to solutions. All right. So please make sure what you take advantage of this to learn it once and for all. All right. Acidic buffers. How are acidic buffer forms? How are acidic buffers formed rather? Acidic buffers are formed by mixing solutions of a weak acid and a salt of the weak acid. All right. So this is how what acidic buffers are formed. They are formed by mixing solutions of a weak acid and a salt of the weak acid. All right. So let's see some common example. A weak acid like H2CO3, right? A weak acid like H2CO3 and a salt of this weak acid, Na2CO3. All right. So acidic buffers are formed like this by mixing solutions of a weak acid and a salt of the weak acid. All right. So another example, of course, is CH3COOH, that's acetic acid, and a salt of acetic acid, CH3COONA. All right. These are examples of of acidic buffers, right? They are formed by mixing solutions of a weak acid and a salt of the weak acid. H2CO3 and Na2CO3, CH3COOH and CH3COONA. These are what acidic buffers. Now, how are alkaline buffers formed on the other hand? Alkaline buffers are formed by, let's get that down. Alkaline buffers are formed by mixing solutions of a weak base, all right, and a salt of the weak base. All right. So alkaline buffers are formed by mixing solutions of a weak base and a salt of the weak base. All right. Let's see an example. Example is what mixing ammonium hydroxide. All right. Or you can use NH3. Then and a salt of this weak base, which is, for example, ammonium chloride. All right. So this is how alkaline buffers are formed. Alkaline buffers are formed by mixing solutions of a weak base and a salt of the weak base. All right. So another example, of course, is CH3 NH2, right, and CH3 NH3Cl, right? Okay, so this is called these are examples of alkaline buffers. They are formed by by mixing solutions of a weak base and the salt of the weak base. I see ammonium hydroxide here and ammonium chloride. We are seeing methylamine, right? Methylamine, all right, and this is of course methyl ammonium chloride. All right, so this is methylamine and methyl ammonium chloride. All right, so these are what are alkaline buffers. Now that we have seen the two types of buffers that we have, the acidic buffers and the alkaline buffers, let me now show you how those hydrogen ions and the hydroxyl ion, right, are mopped out from the solution of buffers. All right, now let's see. Okay, so know this, that acidic buffers are used to maintain acidic environment. All right, acidic buffers, first of all, acidic buffers are used to maintain acidic environment. All right. All right. So acidic buffers are used to maintain acidic environment, and they have acidic pH. All right. Acidic buffers are used to maintain acidic environments, and they have what? Acidic pH. While alkaline buffers, on the other hand, alkaline buffers are used to maintain basic environment, and they have what? Basic pH. All right, so just know these two differences. So the acidic buffers themselves are used to what? To maintain an acidic environment. They used to maintain an acidic environment, and of course the pH will what? Definitely be what? Be acidic. While alkaline buffers are used to maintain a basic environment, all right, and they have what? Basic pH. Now, what happens that in solution, let me put that down. In solution, what happens is that the salt, right, of the weak acid is what? Completely what? Ionized. Is what? Fully ionized. While what? The acid itself is partially or partly ionized. In solution, now, this is what happens. This is how those hydrogen ions and the hydrogen ion are mopped out. This is what I'm trying to show you now, but you have to follow me closely. In solution, right, what happens is that the salt of what? Of the weak acid, the salt of the weak acid, is completely ionized. Now, while the acid, right, is partly ionized. All right, so let's see an example. Let's use CH3 acetic acid, CH3COOH, and CH3COONA as what? As examples, so what to explain this. All right, so now in solution, the salt of the weak acid is completely ionized, while the acid itself is partly ionized. So this is what happened. So CH3COONA. All right, so it's a reversible reaction. I'm going to have what is completely ionized. I'm going to have Na plus, then plus, of course, CH3COO minus. All right, so this is what happens. The salt of the weak acid is what? Completely ionized to give you this. Why the acid itself, CH3COOH, right, is what? Is partially or partly ionized. I'm going to have hydrogen ion, then plus CH3COO minus. So this is what happens. All right. So this is the ionization process. The salt of the weak acid is completely ionized, while the acid itself is partly ionized. Okay. So now, on addition of acid, the protons released by by the acid are removed by the acetate ions to form acetic acid. All right. So this is what happens. This is how this hydrogen ion is mopped out. All right. So on addition, let me put that back, and I need to write it out clearly so that you understand how buffers work completely. All right. So at any level, even when you get to the university, this will still be be valid. Please note this. Note this ionization process. CH3CONA, Na plus CH3COO minus, CH3COH, H plus CH3COO minus. So now, on addition of acid, all right, the protons released by the acid, right, are removed by the acetate ions to form acetic acid. So in that case, now you are seeing that if the protons that are released by the acid are now removed by the acetate ion to form the acetic acid, that means the hydrogen ion has been what? Has been buffered, has been knocked out from the solution. All right. So this is what happened. The protons released, that is the hydrogen ion, then of course, then plus what now? Plus the acetate ion, COO minus. This one is from the acid, All right, will now give us what now? Also a reversible solution. They give us CH3 COOH. This one is from the buffer solution. All right, so this is what happens. All right, so now the protons release. Protons, remember we use what when we say protons, we mean what? Hydrogen what? Ion. All right, so the proton release the hydrogen ion, then plus the CH3COO minus from the acid will give us the acetic what? Acid. This acetic acid, CH3COOH. All right, so this is from the what? From the buffer solution. Now, on addition of base, right, the hydroxide, right, released by the base, are removed by the hydrogen ions to yield water. All right. So on the other hand, the hydroxide ion released are removed by the hydrogen ions to form water. So this is what happens. We are going to have hydrogen ion, then plus the hydroxide ion minus. This one is from the base. All right. Then we are not going to have. It's also reversible. We're going to have water, H2O, from the buffer solution. All right, so this is what happens. This is why the effect of hydrogen ions and the hydroxide ion are not noticeable. They are not noticeable at all, because on addition of acid, the proton released by the acid are removed by the by the acetate ion to form acetic acid. This is the reaction. H plus CH3COO minus to give us CH3COOH. All right, now on addition of base, the hydroxide released are removed by the hydrogen ions to form water. So the effect of these hydrogen ions and hydroxyl ions are not felt at all. They are not seen. So what happens? The pH does not change. For buffers, the pH does not change on addition of little quantities of acid or bases. You get? All right. Now that we have done this, because buffers is a continuance on our topic pH that we talked about and the calculations we did. All right. So now there are some formulas involving weak acid. When you want to solve for weak acid, that you need to take into consideration. Let's see them. Right. So let us know them. We do not want to dabble into it too much. Just know them. So that some of you will say, this formula I've never seen it in my life before. Let me clear that out now. So for example, if you want to calculate pH of a weak acid. So talk about weak acids now. We have negative logarithm to to KAC, to root KAC. All right, this is for pH. Where Ka is acid dissociation constant. The acid dissociation constant. All right, YC is the concentration of the acid solution. All right, so I have negative logarithm to negative logarithm of root Ka times C. This C is not under the square root. All right, times C. All right, now YPOH on the other hand is negative logarithm to root KBC, where of course where KB is base dissociation constant. All right, where KB is base dissociation constant, and here the C here is is concentration now of the base solution. All right, so you must what note that perfectly. Then we have something we call percentage ionization. So percentage ionization is equal to what now? Square root of what? Kb over what? Over C. So please note all these formulas for what? For calculation weak acid, for calculating for doing calculations on what? On weak acids. On weak acids. All right, the formulas are very, very what? Valid. Now that we have seen all this, I want to summarize what we have been talking about so far about what pH. All right, now we have said that what in case you have missed any of the episodes on what on acid base and so, please watch all the episodes. They will help you. All right, so in summary, we have said that what that pH is what negative logarithm of what the hydrogen ion concentration, or negative logarithm of what, or the hydrozonium ion concentration. All right, hydrozonium ion concentration. This is what we say what pH is. But we say POH on the other hand, pH on the other hand is what? Negative logarithm of what? Of the hydroxyl ion concentration. All right, we said this. And now we also had a relationship between what pH and POH. All right, we said pH plus POH is equal to what now? 14. Remember very well, right? This is another water form. So this is 1, this is 2, this is 3. pH plus POH is 14. Then we say if we multiply number 4, multiply the what? The hydrogen ion concentration by the hydroxyl ion concentration. All right, so I'm going to have what? 10 raised to power minus what? 14. All right, this is also very, very valid. So another one which we didn't use very well, this of course is the product of, let me say 5 here, product of the acid dissociation constant times the base dissociation constant to give us what? The water dissociation constant. KW here is water dissociation constant. Let me say water dissociation constant. All right, Ka times Kb is Kw, right? Water dissociation constant. Because on the O3SCHOOL JAMB app, most of the questions you solve there, what you see, some of the questions you will see solved there, this formula is used. All right, so please do not be confused. It's the same thing. It's equals to 10 raised to power minus what? Minus 14. All right. They also have the potential, but that's number 6 now. pKa plus pKb is equals to what? 14 also. All right. So these are all what? These are all formulas what we have what talked about what in pH, in calculating what pH. All right. So please note them very, very well. Now to end this class, I'm going to if you have not what like this video, first of all, that thing you are doing is wrong. You are seeing that thing that looks like this, just click on it, so that what other students like you will easily find this video and learn from it. All right, if you have not subscribed to this YouTube channel, what you are doing is wrong. All right, subscription is FREE, is free to subscribe. Just click on that red subscribe button just below this video right now, and what you will be subscribed to this channel, so that whenever we post any video, you will get a notification on your phone. You'll be reminded on your phone that we have published a new video. You don't need to even come and check yourself. You'll be notified. All right, so it is to help you and it is free. All right, if you have subscribed already, there's no need to click on it again. All right, so now we have seen this I've seen what these formulas. Now I want to tell you, how do you know a strong acid? A strong acid has some certain characteristics. So once you know the characteristics of a strong acid, then it will be easy for you to know you know whether this acid is strong or weak. All right, so it helps to differentiate whether an acid is strong or weak. Let's see some of these characteristics. All right, so let's see characteristics of a strong acid. What does a strong acid have? Right, what characteristics does a strong acid have? Number 1, a strong acid has a high hydrogen ion in concentration. So a strong acid will have is a high hydrogen ion concentration, isn't it? Simple as ABC. And a strong acid will also have a low pH. All right, it will have a low or okay, let me say a small pH. A small pH, because I told you if you see your pH meter from 0 to 14, where 7 is the neutral point, pH is generally from this place now to this place. This is for acids. So they are lower than what than base than what that goes from here to what from here to here. All right. So okay, it can be more than 14 anyway. The a pH can be more than 14. A pH can even be less than 0. All right, but I just want to let you know that lower pH are for acids, higher pH are for what? Are for bases. All right, that's how we say that what a strong acid will have a small pH. It have a small pH, and if it's having a small pH, number 3, it means you have what? A low hydrogen ion what concentration. All right, so it will have a high hydrogen ion concentration, a small pH, a low hydrogen ion concentration. It will also have a large POH, a large POH. All right, potential of what? Of the hydroxide what ion. It will have a large what? POH. It will have a large POH, and then also it will have a small Kb value. All right, it will have a small base dissociation constant value. The value for the base dissociation constant will be very, very well small. Okay, this is 1, 2, 3, 4, 5. Then let's look at 6 now. It will have a small pKa value. pKa value. All right, these are all characteristics of what of a strong acid. It will have a small pKa value. It will have a small Kb value, and then lastly, it will have what? A large pKb value. All right, so these are what characteristics of what strong acids. So if you know what all of these were characteristics for strong acid, you will know that what the opposite to what would be for bases. All right, for what for weak acids rather. The opposite would be for weak what acids, of course. So please note them and what just note them once and for all. If you want to be a chemistry student, there are some things you have to what you have to know. So please, this is where we're going to what end this video. In our next episode, we're going to be talking about our salts, and that will be like the last part of what studying acid, bases, and salts. All right. So please make sure you like the video, make sure you subscribe, and make sure you share this video to others so that they can also learn. My name remains Owolabi Tango, your favorite chemistry teacher, and I'll see you in the next class.